Hi dear students, how are you? After long days I getting the chance to see you. Very nice to see you dear students. I am Selvarasu, your physics teacher. I hope all are fit and fine in your home. Dear students, we know that due to the corona pandemic, the whole country has locked down itself. The country is struggling with schools, teachers and lack of education. Most of the schools of the country have started online classes. Dear students, you must take advantage of this opportunity. Our school management also started this channel for giving the online classes to continue your study. It is easy to make the connection with you all and it will help us to cover the syllabus and to maintain the flow of study. And this connection is not limited to the class, but this session will be available for all. And I recommend you take the practice in physics, especially formulas, units, and explanations, definitions, diagrams, and other facts also. I will love to see your individual's talent and strength. Dear students, if you have any query, you can ask in the WhatsApp group. I welcome you all to join the online classes. I hope to see you soon in the class. Stay home, stay safe. Dear students, in our previous classes, 10th standard physics, we have discussed number of topics, especially force and different types of force, and then kinematics, statics, kinetics, and other facts. Newton's first law of motion, second law of motion, third law of motion, Newton's second law of motion, proof, which means derivations, examples for Newton's third law of motion, and examples for Newton's first law of motion, impulse, inertia, types of inertia, and different types of topics we have discussed in our previous classes. Dear students, in this session, we are going to discuss about the topic name is Newton's law of gravitation. Newton's law of gravitation. What is the name of the topic? Newton's law of gravitation. Dear students, let us see what is the definition for Newton's law of gravitation. According by that definitions, it is saying every object attracts every other object in the universe with the force that the force is directly proportional to the product of their masses and inversely proportional to the square of the distance. This is the definition for Newton's law of gravitation. So I will explain through this diagram. So let us consider two objects A and B of masses m1 and m2. The two objects are separated by the distance r. So we are going to consider two objects A and B of masses m1 and m2 separated by the distance r. So this part is to be the center of this object. Okay. Now according by these definitions, what is the definition saying? So every object, let us consider every object attract every other object. Okay, every other object. So if two objects wants to be attract each other means, so what is necessity there, what's needs there, definitely force should be there. So force is playing very major role there. So here if you take that, definitely this object is wants to attract other object means definitely here force is must. Okay, so that force is directly proportional to the product of their masses, which means if you multiply this mass, that is said to be product of their masses, and inversely proportional to the square of the distance. Okay, so according to this statement, every object attract every other object in the universe. This is applicable for only universe. Okay, so with the force, which is symbol denotes the force F, that force is directly proportional to the product of their masses. So this is m1 and this is m2. So mass of the first object m1 and mass of the second object m2. So this is said to be product of their masses. Okay, and according by the statement or definitions, what is the another one statement? Now, what is that sentence saying? What is that? That force is inversely proportional to the square of the distance. So what is the distance here? R is the distance. Okay. So this is the Newton's law of gravitation. So let us say this is the equation number 1 and this is the equation number 2. Every object attract every other object in the universe is directly, what is that, with a force, that force is directly proportional to the product of their masses and inversely proportional to the square of the distance. Can you understand, dear students? Okay, so from the, according to the statement, from this equation number 1 and 2, what is that, if you combine this equation number 1 and 2, combine equation number 1 and 2, what will we get here? So equation number 1, what is that? This is a common F. F is directly proportional to product of their masses m1 and m2 divided by inversely proportional to the square of the distance. Okay. Now one thing you should keep in your mind. Okay. So if you want to remove this proportionality, definitely we should add the one constant. Okay. So what is the, which constant is sufficient to here? Universal gravitational constant. Which symbol denotes the universal gravitational constant? The symbol G denotes the universal gravitational constant. So whenever we are removing the proportionality, definitely we should add the one constant. So which is symbol F equal to, instead of this proportionality, we are adding G. G is nothing but universal gravitational constant G m1 m2 divided by what will we get here? R square. Okay, so this is the final formula. And if you need this, if you want this universal gravitational constant, so what will be getting? G equal to, so in this R square, if it is what is that, goes from denominator to left hand side, what will be getting here? So definitely it is the convert to the multiplication. So F dot R square divided by m1 m2. Okay, so now what should we do? We should write the unit, give the unit for this universal gravitational constant. So what is the unit? Unit for universal gravitational constant. How can we write? See here, F is nothing but force. The unit of force is Newton, and this is the R square, which means distance. Okay, so the distance we are measured using by the, what is that unit? Meter. So here R square is there. What will be getting here? Meter square will come divided by, so what is the unit of mass? Kilogram, and two mass is there. Mass of the first object, and mass of the second object. So kilogram and the kilogram into kilogram. Kilogram square will come. So the kilogram square is what is that now? Goes from what is the denominator to numerator. So it is the Newton meter square. Kilogram power minus 2 will come. So this is the unit for what is that? Universal gravitational constant. What is the G denotes? G is nothing but it is the universal gravitational constant. Dear students, should keep it in your mind. Why? Because sometimes they may ask the question in the 1 mark. Okay, so unit G equal to Newton meter square kilogram power minus 2. So this is the final units for universal gravitational constant. This is the, what is that? Formulae or derivations for Newton's law of gravitation. What is the Newton's law of gravitation saying? Every object in the universe attracts every other object is directly proportional to the product of their masses and inversely proportional to the square of the distance. Okay, so the force is acting, what is that? Opposite directions each other. Why? Because according to the Newton's third law of motion. Okay, dear students, the value of G equal to 6.673 or 6.674 into 10 to the power of minus 11 Newton meter square kilogram power minus 2 will come. Okay, so how can we get these values? Already we found formula for universal gravitational constant. G equal to F is nothing but force of the object, and the R is nothing but distance between two objects, and M1 M2 is nothing but mass of the first object and second object. So if you know these values, that known values, substitute within the formula, we can get the answer 6.674 into 10 to the power of minus 11 Newton meter square kilogram power minus 2. Okay, so the next topic we are going to discuss about the acceleration due to gravity. What is the next topic name? Acceleration due to gravity. Acceleration due to gravity. This is nothing but, dear students, let us consider when we throw the one object, while it is going higher and higher, it reaches certain height. What will be get? The velocity of the object ceases. After the velocity of the object gets ceasing, what will happen? It is start to fall down. So let us consider one man is standing here. He is throwing one object upward directions. When it is going higher and higher, at certain stage or at certain height, it becomes the velocity of the object ceases, which means the velocity of the object becomes zero. So after it attains the zero velocity, it start to falls down. Why the object after what is that attains the velocity of the object zero, it is start to falls down because of the earth gravitational force. The earth gravitational force acting on an object and make it to push down. So when it is object comes to the earth, what's happening there? The velocity of the object will be changes. Already we have studied in the lower class itself the rate of change of velocity, which means the velocity changes, the object velocity changes with respect to time. That is we said to be what is that? Acceleration. Okay. So here the acceleration, so the velocity of the object changes with respect to earth gravitational force. So that's why we are saying what is that? This is the acceleration due to gravity. So whenever we are throwing the object upward direction, it what is that? At certain height, the velocity of the object ceases, which means it becomes a zero. The velocity of the object becomes zero. After what is that? The object comes to what is it? It is start to falls down. When it is falls down, what will happen? Especially now the velocity changes. Why the velocity changes? Due to the earth gravitational force, which means the earth gravitational force acting on an object and it makes velocity changes. So the velocity changes, that is we said to be what is that? Acceleration due to gravity. Okay, so this is the acceleration due to gravity. Which symbol denotes the acceleration due to gravity? The symbol G denotes the small g denotes the acceleration due to gravity. So what is the value of acceleration to gravity? What is that? The value of acceleration to gravity is 9.8 meter second power minus 2 will come. Okay, at what is that? Sea level of 45 degree latitude, so we can get the value of 9.8 meter second power minus 2. Okay, again one more time, clearly I am saying, dear students, while we are throwing any object upward direction, the object reaches at certain height, the velocity becomes what is that? Zero, which means ceases. Then it is falls down. While it is falling the object, the velocity will be changes. So the rate of change of velocity is said to be what is that? Acceleration. Why the velocity changes? Because of the earth gravitational force acting on an object. So that's why that is said to be acceleration due to gravity. Can you understand, dear students? Okay, dear students. Now we are going to discuss about the topic name is relation between small g and capital G. Relation between small g and capital G. Small g is nothing but, already told you, acceleration due to gravity. Capital G is nothing but universal gravitational constant. The value of small g 9.8 meter second power minus 2. The value of capital G is 6.674 in 10 to the power of minus 11 Newton meter square kilogram power minus 2. Isn't it, yes or no? Now we are going to discuss what is the connection between small g and capital G. Okay. So now we are going to discuss two objects. One object is nothing but earth. We are considered as one object. This is nothing but earth. One object is placed. Okay, one object is placed at the surface of the earth. So this is the surface of the earth. This is the object. What is this? Object. And this is the earth. This is the center of the earth. This is the center of the object. This object is lying, which means placed on the surface of the earth. Okay. So now, what is that? So how can we? So what is that? How we are able to? The object is placed on the surface of the earth because of the gravitational force is acted. Okay, acted by the what is that? The gravitational force is acted by the earth. Or otherwise we can say like this. Okay, so the earth exerts the gravitational force on this object. So that's why the object able to stand or lying on this surface of the earth. Isn't it, yes or no? So now the mass of the earth, let us say capital M. and mass of the object, small m. The radius of the earth, capital R. So now the force acting towards the surface of the earth. So this is said to be F towards these directions. Okay. So now we are going to derive or let us see what is the relation between small g and capital G. So while we are placing the object at rest state on the surface of the earth, the two are acted by the gravitational force, earth gravitational force. Now if you want to be find out the force if you want to be calculate or compute the gravitational force, which means force, what is that, in two ways. The first way is, what is that, especially now we can find out or compute using by the Newton's law of gravitation. The another way is we can find out or compute the force using by the Newton's second law of motion. There are two ways. The first one is Newton's law of gravitation, second one is Newton's second law of motion. Okay. Now the mass of the earth concentrated at the center of this, what is that, earth. Okay. So now we are going to, what is that, find out the force, or the force is acted, what is that, according by the Newton's law of gravitation. We know that already, formula F equal to G, what is that, m1 m2 divided by r square will come. Okay. So one thing you should keep in your mind, dear students, there are two different objects we are considered. So mass of the first object is m1, mass of the second object is m2. So here earth itself, okay, we are what is it, considered as a first object, and the object considered as a second object. Now the mass of the earth is said to be capital M, the mass of the object we are said to be small m. So here this is the first object, so that's why instead of m1, or we can write like this, m1 equal to capital M and m2 equal to small m will come. Why? Because we are giving the name like that. Okay. So that's why instead of what is that, m1 and m2, we should apply here, what is that, capital M and small m will come. Okay. G capital M small m divided by r square. So this is the according by the Newton's what is that, law of gravitation, this force will come. Okay. And the second one is according by the Newton's second law. So let us say this is the equation number, what is that, equation number 1. And second one, according to the Newton's second law of motion, what is the Newton's second law of motion saying? The rate of change of momentum is directly proportional to the applied unbalanced force. Okay. So force equal to mass into acceleration. So full and full we are discussing about here acceleration due to gravity, universal gravitational constant. So this is based on the what is the gravitational force. So that's why, so here acceleration is equal to acceleration due to gravity. A equal to small g will come. Okay. So now F equal to m into, instead of a we can substitute these values, what is it, m into g will come. So F equal to mg will come. So this is let us say equation number 2. So this is equation number 1 and this is equation number 2. So now from this equation number 1 and 2, what will we get here? So from equation number 1 and 2, so what is that, equation number 1, sub 2, mg equal to capital G, capital M, small m divided by r square will come. So here you should keep in your mind, capital R we are giving here name, so that's why instead of small r we use it capital R here. Okay, r square. Now see, get cancel. So what is the values there? G equal to gm divided by r square will come. So this is the relation between small g and capital G. So this is the final value. So already given the value for small g. So what is the value of small g? Acceleration to gravity 9.8 meters second power minus 2. So already we know that value. What is that, capital G? 6.674 into the power of minus 11 Newton meter square kilogram power minus 2. So already mass of the earth is 6 into 10 to the power 24 kilogram, and the radius of the earth we can write like this also, 6,400 kilometer or 6.38 into 10 to the power of 6 meter. Okay. So these values are we said to be known values. So these known values, while you are substituting within the formula, definitely you can get out. What is that? Values G equal to 9.8 meter second power minus 2. Can you understand, dear students? So this is the relation between small g and capital G. Next we are going to discuss about the topic name is mass of the earth. So how to find the mass of the earth? For finding the mass of the earth, it's not very difficult, dear students. It's very simple. If you rearrange these equations, definitely you can find out the mass of the earth. Okay. So small g is nothing but acceleration to gravity. Capital G is nothing but universal gravitation constant. Capital M is mass of the earth. Capital R square is radius of the square of the radius of the earth. Okay. So if you want to find out mass of the earth means if you rearrange these equations, definitely you can get the answer. So what we need, we have our aim is to find out the mass of the earth. So mass of the earth M equal to what will we get here? G R square divided by capital G will come. So this is the mass of the earth. Okay. So what is the approximately we can say mass of the earth is 6 into 10 to the power of 24 kilograms. So this is the mass of the earth. Okay. The value, no, what is that? G 9.8. The value of G is 9.8. What is that? Radius of the earth is 6,400 kilometer divided by 6.674 into 10 to the power of minus 11. These values substitute in the formula, you can get the value of this. Okay. So next we are going to discuss about the topic name is variation of the acceleration to gravity. What is that? Variation of the acceleration due to gravity. Okay. Dear students, let us consider this is the earth. Okay, what is that? Earth. This is the center of the earth. Okay, what is this? Center of the earth. Now, this is we said to be, what is that? Equatorial region, and this is the polar region. So this part we can say radius of the earth. Even this also we can say radius of the earth. So this is what is that? Geometric radius of the earth. So in the equatorial region, the geometric radius of the earth is maximum. So in this region, the geometric radius of the earth is minimum. Why? Because this is a distance more distant, this is a less distance. So two distance is not same. So it is vary from each other. Okay. So this is the maximum distance. This is the less distance. So that's why we are saying this is a geometric radius of the earth is maximum here. Here geometric radius of the earth is minimum. Okay. So how can we find out variation of the G? G is what is that? Not same at all places. It will be vary from place to place. Okay. So now so according by this statement, G is inversely proportional to the square. Now what is that? Square of the radius of the earth. Which means if you see here, according to what is the inversely proportional? Inversely proportional is nothing but one increases, another one decreases. One decreases, another one increases. This is the inverse meaning of inversely proportionality. Okay. So in case if acceleration due to gravity increases, the radius of the earth decreases. In case if the radius of the earth increases, acceleration to gravity decreases. Okay. So if you look at this, so here see the geometric radius of the earth is maximum, which means more. What about the acceleration to gravity? Less. Acceleration to gravity is less. So suppose here the geometric what is the radius of the earth is very less, so the acceleration to gravity is more. So that's why we can say the acceleration to gravity is what is that? Less at the equatorial region, more less at the equatorial region, more at the polar region. Why? Because see here distance is more, so that's why acceleration to gravity is less. Here distance is less, acceleration to gravity is more. So that's why we are able to say, so geometric radius of the earth is maximum, acceleration to gravity is minimum. The geometric radius of the earth is minimum. The acceleration to gravity of the earth is maximum. So this is the variation of acceleration to gravity. The one more thing you should keep in mind, dear students. So what about the acceleration to gravity at the center of the earth? What is that? 0. What is that? 0 at the center of the earth. Minimum at the equatorial region, maximum at the polar region.